All right, hello. We are going to be starting Unit 6 today, which is all about higher order functions and finding zeros. Okay, so the first thing we're going to be looking at is kind of how to graph these higher order functions. And there's lots of little tools that help us do that. Okay, in behavior lets us know what the ends are doing. Okay, local behavior tells us kind of what's happening around all the different x-intercepts. And then we're also going to learn how to just go ahead and graph the whole thing. So we're going to jump in. So I call this graphing higher order functions because it encompasses a lot of topics. But the actual assignment that we're going to be looking at for this video is in behavior of polynomial functions, which has to do with graphing. Okay, but this is the actual assignment that's tied to this lecture. Okay, all right, so in behavior of polynomial functions, the way that we determine the end behavior is we only need to know two things. If we have our function, we need to know what our leading coefficient is, okay, and we need to know what the highest power of that polynomial function is. So if we have something like 7x to the 10th, right, we would know that 7 is our leading coefficient and 10 is the power, the degree of that polynomial. Okay, so we need to look at this highest degree term because that is what allows us to determine our end behavior. Okay, so we have this neat little chart to help us out here. Okay, so when we look at end behavior, the first thing we look at is our leading coefficient. So whatever this number is that's in front of our highest power of x, okay, that's our leading coefficient, and the leading coefficient tells us what the right side of the picture does, okay? So it tells us if the right side goes up or down, okay? So what I mean by that is, notice we have all these pictures here, okay? Here it says if we have a positive constant, right, or coefficient, let's just say coefficient, not constant. So if our coefficient is positive, notice this right side is going up, right? Notice here, or actually it doesn't matter if it's even or odd power, if our leading coefficient is positive, notice the right side goes up. Same thing over here, the right side goes up. Okay, if we have a negative coefficient, this is going to drive me crazy, positive k, okay, or negative k. All right, if we have a negative leading coefficient, then notice our right side goes down, okay, on both of these, okay? So we're either going to see that our ends go the same direction, either they both go up or they both go down, or they're going to go opposite directions, right? But the right side, the behavior of the right side as x goes to infinity, is determined by whether or not that leading coefficient is positive or negative. If it's positive, the right side will go up. If it's negative, the right side will go down. Okay, so we know what the right side is doing. Now we need to be able to determine what the left side is doing. Well, there's a way to determine if the sides go the same. You know, once we know what the right side's doing, we should be able to say, oh, well, the left side should be doing the same thing, right? Or if we know the ends are opposite, then once we know what the right side's doing, we know the left side should be doing the opposite of that, okay? So to determine whether the ends go the same direction or the ends go opposite directions, we actually look at the power or the degree of that polynomial, which is this highest power of x. So if the highest power of x is like an x squared, for example, okay, that would be a parabola. Notice x squared, that's a positive, an even power, right? 2 is even. And with a parabola, both sides go up. So notice if it's even power, both sides go up or both sides go down, right? The ends go the same when it's an even power. Or if we have something like an x cubed, okay, because that would be a high power of 3. 3 is odd, so ends would go opposite, okay? So down here it says degree of the polynomial tells us if the ends go the same direction or opposite directions. Okay, so all we have to do is look at this little number, whatever this is. So let me just give you an example. So let's just say, for example, let's say we have f of x equals negative 3x to the fourth. Okay, so notice I see a negative leading coefficient. So this negative leading coefficient, remember, tells us what the right side does. So if it's negative, that means that the right side goes down. Okay, right? Negative leading coefficient means the right side goes down. So either both sides go down, or the right side's going to go down and the left side's going to go up. So it has to be some picture similar to this. So then we look at our degree here. Our degree is 4, which means that it's even. And if our degree is even, that means that our ends go the same direction. Okay, so we know that the right side's going down. Since it's even, the ends go the same direction, so the left side should be going down. We don't really know about anything that's going on in the middle of the function. This just tells us what the ends are doing. Does that make sense? Okay, now one thing you do need to be aware of is the way that these are written. Okay, when we talk about what end behavior, what's happening at the ends, we talk about that in a directional sense, meaning we talk about as x gets bigger, what is our y doing? And as x gets smaller, what is our y doing? So remember, as x gets bigger, this is going to positive infinity, right? And as x gets smaller, this is negative infinity. And then the same thing with the y's, right? As y's get bigger, this is positive infinity. And as y's get smaller, this is negative infinity. So what this is saying for this picture is that as x goes to negative infinity, okay, as x goes to negative infinity, so that means as x goes out to the left, notice as x's go to the left, my y's are increasing. So they're going up towards infinity. So that's what this notation means. As x gets smaller, my y's get bigger, right? And the same thing to the right. As x gets bigger, or as x goes out to positive infinity, notice my y's go up to positive infinity. So that's what this notation means. So once we find our picture, so let's say this is our picture, okay? If I want to think about this on a graph somewhere, okay, as x's, here, let me just write, as x goes to infinity. So if I look at this picture going in the right direction, okay, so think about there being an axis, and I don't know where the axis is on this, okay, we can kind of pretend, maybe the x-axis is here. We don't actually know, okay? But as we go out in the right direction towards positive infinity, notice my right side's going down. So that means that my f of x's, or my y's, are going to go to negative infinity, okay? As our x's go out to the right, our y's go down. Or in other words, as x goes to infinity, f of x goes down to negative infinity, okay? And then we need to state the other direction too. So if we go to the left, that means x is headed towards negative infinity. And as x goes out in this negative direction, notice the left side goes down. So that means that my f of x's are going to negative infinity in that direction too. Okay, so this is just kind of a fancy way of saying the right side goes down and the left side goes down, right? Or the right side goes up and the left side goes up, or whatever the case may be. But this is a notation that you're going to see in your homework and possibly on a test. So I want you to be familiar with it. So what we're going to do is look at some examples kind of using this chart to determine the right, what the behavior of the right is, and if our ends go the same direction or opposite, okay? We're going to sketch a little picture and then we're going to write out a description of the behavior. Now, as you're doing your homework and things like that, you can refer to this chart to help you out, but on an exam, you won't be given this chart, okay? So you need to be familiar with knowing that that leading coefficient tells you the right behavior, and that degree of the polynomial, it being even or odd, tells you whether the ends go the same or opposite, okay? All right, so let's look at some. We have all these lovely examples. So it says determine the end behavior of each polynomial. Now notice in this case, when I talk about a polynomial, I need to know that highest degree term, right? And right now this is written in factored form, so I can't see the highest degree term. So what I would have to do is multiply this all out, right? Okay, so when I multiply this out, I would get 10x to the 7th plus 5x to the 6th. So this is going to be my leading term, right? So when I look at that leading term, I can see that my leading coefficient is positive. And if my leading coefficient is positive, remember that tells me what the right side does. So that means that the right side is going up. okay? And then I look at the degree. The degree is odd, and if the degree is an odd number, that means that my ends go opposite direction, okay? So now I should be able to sketch this. So I know that the right side goes up, and since my ends are opposite directions, that means that the left side has to go down, okay? I don't really know what's going on in between, and I don't care. I'm just looking at end behavior. So I want to be able to write this using that mathematics notation that says as x goes out to positive infinity, okay? So as x's go out to positive infinity, remember that means x's are getting bigger. So as we go to the right, here the right side's going up. So that means our f of x's are also going up to positive infinity because they're getting bigger, right? Then we want to look in the other direction as my x's get smaller, or as our x's go out to negative infinity to the left, notice my function is going down. So that means that my f of x's are going to negative infinity, okay? So this is what I'm looking for, okay? So we're using that leading term to figure out what the right side is doing based off of the coefficient and what the ends are doing based off of that highest power of x. Then we can sketch a little picture and write out our behavior. Okay, now I want to show you a little bit of a shortcut because I really don't want to have to multiply these guys out, honestly. So let's look at our leading term here. I got this leading term from doing 5x to the 6th times 2x, right? I didn't really need to multiply this by the 1 to determine the end behavior, right? I only needed to look at this highest degree term. So what we can do as a shortcut is we can just look at what pieces of this function, when I multiply them together, are going to give me that highest degree term, right? So let's look at this one. Well, this one only has one term, negative 3x squared, so that's gonna take part in my highest degree term. Inside this factor, the highest degree term is the x, right? And in this factor, my highest degree term is also an x. So my highest degree term for the whole polynomial, when I multiply it out, is going to be the term that I get from multiplying negative 3x squared times x times x. So I'm just going to write that down here. I'm just going to look at negative 3x squared times x times x. I don't care about what the rest of it equals because I just want to see that highest degree term. Okay, so when I multiply all this out, I'm going to get negative 3x to the, I add exponents, right? So 2, 3, 4. Okay, and now I can determine, right, this is going to be my function, and then it's going to have all those other terms that I don't care about. So once I know my highest degree term, again, I look at that coefficient. The coefficient tells me what the right side is doing. So if the right side is negative, that means it's going down, right? So right side goes down. And then I look at this highest degree term. The highest degree term here is even, which means that the ends are going the same direction, okay? So I'm going to sketch a little picture. I know that the right side goes down, and because the ends go the same direction, that means that the left side must also go down. And I don't really know what's going on in between, and I don't need to know. I just need to know what they're doing. So now I want to write out what's happening as x gets bigger and as x gets smaller. So remember, as x gets bigger, that means we're going out in the right direction. So we know the right side is going down, which means that my f of x is going to negative infinity. Okay? And then we want to look at this picture going to the left, or as x goes to negative infinity. Okay? So as x goes to negative infinity, notice the left side's also going down. So that means f of x goes to negative infinity. Okay? So we go ahead, circle that. Let me look at one more and then I'll have y'all try some. Okay? So let's look at the next one. Again, I really don't want to have to multiply this whole mess out. And so I'm going to identify the highest degree term of each factor so I can just multiply those together to see what that leading highest degree term would be. Okay, so I have my x cubed out here. It's the only term, so I have to take it. Inside this quantity, the highest degree term is the one with the x. So I'm going to take negative x. And then inside my next quantity, the highest degree term would be 2x. Okay, remember highest degree just means whichever one has the highest power of x, right? So I'm going to multiply those two together. So I know that f of x is the same thing as, and when I multiply those together, let's see, I have x cubed times negative x times 2x, right? So that's going to give me, let me move this down, f of x equals negative 2x to the what? 3, 4, 5? Okay, so that's going to be my highest degree term, and then of course I would have a bunch of other terms out there, but I'm not going to multiply it all out. All right, so now that I have my highest degree term, I should be able to determine what my ends are doing. I look at my coefficient, which is a negative 2. So that tells me what the right side is doing. Because it's negative, that means that the right side is going down. Okay, then I look at the degree. It's odd. So anytime I have an odd degree, that means that my ends are going opposite directions. Okay, so I start with the right side's going down. If I know my ends are going opposite, that means the left side has to be going up, and I don't really know what's going on in between, right? So now I want to go ahead and write it out with my infinity symbol notation here. So as x goes to the right, or to positive infinity, my y values are going to go down to negative infinity. So f of x goes to negative infinity. And as I look at this function going to the left, or as x goes to negative infinity, then notice my y values are going to go up, or up to positive infinity. Okay, so we just leave it like that. All right, so there are two for you to try. Go ahead and pause the video, and whenever you're ready to check yourself, or if you get stuck, unpause it and we'll see how you do. All right, so as we look at these first two practice problems, if we look at our highest degree terms, it's negative 8x squared and negative x. And when we multiply those together, we would get a positive 8x cubed. So right side's going to go up because we have a positive coefficient, and our ends are going to go opposite because we have an odd power. Okay, so our little picture should look something like this, with x increasing means y increasing, and with x decreasing means y is decreasing, okay? On the second one, we look at all the highest powers of x. So we have a negative x squared, we have a positive x, we have a negative x, and we have a positive 4x squared. So we multiply all those together, our leading term should be 4x to the 6th, okay? Our leading coefficient is positive, so the right side is going to go up, and our degree is 6, which is even, so our ends are going to go the same direction. So since the right side's going up, that means the left side also has to go up. Okay, so our little sketch should look something like this. So as x increases, so does y. As x decreases, oh, that's not correct. That should be a positive infinity. So pretend that's not there. There we go. Hey! So they both go up to positive infinity. Okay? All right, so I want to look at a couple examples of a little bit deeper thinking. So here we have a problem that says which factor could be part of the function so that the function is decreasing on the right. Select all that apply. Okay, so all it tells us is that we want something that's decreasing on the right. Okay, so what that means, what could a function look like that's decreasing or going down on the right hand side? Well, if it's going down on the right, it could also be going down on the left. So it could be something that looks like that, right? Or if it's going down on the right, it could be also be one that is going up on the left, right? It could be something like this. So this is what we want. We want a function that's going down on the right. So either we need both sides down or we need the right side down and the left side up. If we can come up with something that looks like that, then it satisfies what they're asking us for. Okay, so what I want to do is I want to go ahead and see what our leading coefficient is here. Okay, and then they're saying if we were to put on this additional factor, would we end up with one of these? Would we end up with something that looks like that? Okay, so let's go ahead and figure out our leading terms here. So this leading term, we have an x, inside here we have an x, and inside here we have an x, right? So that means when we look at this one, we're going to have an x times an x times an x, which means we have an x cubed. Now, I'm not actually going to look at what that shape looks like because I'm not just thinking of just this original function. I want to know if I take that leading coefficient and I multiply it by one of these factors, will I end up with something that gives me that shape? Okay, so if I were to take x cubed and multiply it by -4, I want to know if I get one of these shapes. Okay, so that's what I'm going to do. I'm going to go ahead and just write over here, if I do -4 times x cubed, that's what's going to give me my new leading coefficient, right? Which is equal to -4x cubed. So what that tells me is since my leading coefficient would now be negative, the right side would be going down, right? And my degree is odd, so that means my ends are going opposite. So if the right side goes down, left side goes up. So it looks something like that. So if I were to multiply this -4 factor onto my function, what this is telling me is that I would end up with something that has the right side going down, or that is decreasing on the right, right? This matches one of those shapes that I wrote up there. So this one is going to be one of my solutions, okay? So we're going to do that and check for each of these. So again, I already know my leading coefficient right now currently for my function is x cubed. So if I put this additional factor on of positive 1/2 x, I want to see what that's going to look like. So if I take 1/2 x and I multiply it by the x cubed, I'm going to end up with 1/2 x to the 4th, right? Now, 1/2 tells me that because I have a positive coefficient, that the right side is going up, right? Right side up. And then because my degree is even, that means the ends go the same direction. So if my right side's going up, my left side's going up. Okay, so notice this shape does not match the shapes that I want because I want one that's decreasing on the right. And notice this is not decreasing on the right, it's increasing on the right. So that's not going to be one of my answers. Okay, so let's go on to this one. Now, when I look at this one, notice I have it kind of in factored form because I have this negative factored out. So I have to think about what would be the leading term of this quantity, okay? I would need this 2x, right? That's my highest degree, but I also have this negative out here. If I were to distribute that negative in, it's going to change the sign of that 2x, which is my leading term. So I'm going to go ahead and consider this that I need the negative and the 2x because that's going to change that highest degree term. Okay, so that means that I'm going to do -2x times the highest degree term that I currently have in my function, which is x cubed. Okay, so that's going to give me -2x to the 4th. Okay, and -2x to the 4th has a negative coefficient, right? Negative coefficient means that the right side goes down, and because we have a power of 4 that's even. When our degree is even, our ends go the same direction. So if the right side's going down, then the left side is also going down. Okay, so notice this one does look like one of the shapes that we want, right? As long as that right side is decreasing, then that is a factor that will give us the shape that we want. Okay, does it kind of make sense? So you're just working through each one to see if you added, or sorry, multiplied that factor onto our function, if it would give you this desired shape. Okay, so let's look at this one. The highest degree term of this quantity, if we were to put this quantity up here and multiply it on, is the 4x, right? So if I do 4x times the x cubed, which is the leading term of my original function, I would get 4x to the 4th, right? So now if I look at this, my leading term is positive, which means that my right side goes up, and my degree is 4, and since that's even, that means my ends go the same direction. So if the right side's going up, that means that the left side's going up. And honestly, on this one, I could have stopped as soon as I saw the right behavior, right? Because as long as this right side's going up, I know this one is not my desired shape, right? Because I want it decreasing to the right. I need the right side going down. So as soon as I see this one's going to be going up, I know it's not going to be a solution, okay? All right, let's look at this one. This one's a little bit more tricky, right? Because there's, it's kind of like this one that we did up here that had the negative outside. If there's the negative 2/3 outside, I have to take that into account. Yes, my x squared is my highest degree term, but if I were to multiply this negative 2/3 in there, that would change the sign, right? So I'm going to take the negative 2/3 and the x squared. So I would get negative 2/3 x squared times the x cubed that I already have, right? And multiply it together, which gives me negative 2/3 x to the 5th, okay? And then I look at my leading coefficient, which here is negative, so right side down. And then my highest degree term is 5, which is odd, which means that my ends are going opposite. So right side down implies left side up. Don't know what's going on in the middle, but because this right side is down, it matches my desired shapes. So that is also going to be a solution. Okay? All right, so there's one for y'all to try. Same type of mentality. It's going to give you a function, and you're going to determine which of these factors, if you multiply these factors onto your function, would be increasing on the left. So before you get started, make sure you know what increasing on the left shapes look like, and then work through these, okay? And go ahead and pause the video and then unpause it when you're ready to move on. All right, so when we go over these practice problems, notice for this one specifically, we want increasing on the left and decreasing on the right. That means our right side is going down, right? And increasing on the left means our left side is going up. Okay, so what I'm going to do is just figure out all the shapes for each of these and then see if it matches what it is that I want. Okay, so notice in our original we have an x in our first quantity being the highest order term of that factor, and an x in the second quantity being the highest order term of that factor. So x times x gives us an x squared. So that's what we're going to multiply by each of these terms to determine that new leading coefficient. Okay, so when I multiply my x squared by negative 0.8, I'll have a negative leading coefficient, which means right side down. And because it's a square and an even exponent, then the ends are doing the same thing. So if the right side's going down, this one's going down. Which notice this shape does not match what I want. So that is not part of my answer. Okay. On the next one, when I multiply negative 3x times the x squared of my original function, I get negative 3x cubed. The negative 3 tells me that the right side goes down, and the cube tells me that my ends are opposite. So if right's going down, left's going up. And you can see that that matches the shape that I want. So that second choice is one of my solutions. Okay. Now the third choice, I only want to multiply it by the x in that quantity because I only want the leading coefficient. So x times the x squared from my original gives me x cubed. And if there's no number written out front, remember that's an implied 1, a leading coefficient of 1. And it's positive, so my right side's going up. And then because I have a cubed exponent, my ends are opposite. So left side would go down. So notice this does not match the shape that I want, right? Then I look at my fourth option here. I do need to distribute that negative in here and take the whole negative 2x to multiply times my x squared from the original. So negative 2x times the x squared from my original is going to give me negative 2x cubed. The negative 2 tells me that the right side goes down. And then the cubed exponent tells me that my ends are opposite. So if right is down, left is up. And you can see that this matches that desired shape that I want. Okay. And then the last one, I multiply my x squared by the highest order term in this factor, which is 3x squared. X squared times 3x squared gives me 3x to the fourth. The leading coefficient is positive, so that means the right side goes up. And my degree is even, so that means my ends are the same. So if right's up, left's up, okay? And this does not match the desired shape that I wanted for this section, okay? So that is the end of the end behavior of polynomial functions. So you should now be able to complete that homework assignment, the end behavior of polynomial functions, on your Knewton Alta assignments. And if you have any questions, please let me know.